Good evening, children. Good evening.
Good evening, ma'am.
Good evening.
Good evening.
Good evening. Should we continue from this one, children?
Yes, ma'am.
Last one.
Completed, ma'am.
We finished this, right? Yeah. Okay, so we'll have to continue from here. How do we find the area for rhombus? We know two formulae to find the area for rhombus. What are they?
1/2 D1 into D2, ma'am.
Half D1, D2 square units, and the other one?
Base into height, ma'am.
Base into height. Am I audible and clear, children?
Yes, ma'am.
All right. Yeah, so in this question, find the area of a rhombus whose side is 5 centimeters. Side meaning base. Find the area of a rhombus whose side. You can make a note. Side meaning the base is 5 centimeters and whose altitude is 4.8 centimeters. So we are given the base and the altitude of the rhombus. So it's easy to find the area, base into height. Now, if one of its diagonals is 8 centimeter long, find the length of the other diagonal. So now we've got the area. We have the area with us. So say the area is, some 24 centimeters square. Okay, the area is 24 centimeters square. Now, what should you equate that to? You should equate that to what? You will find the area using base into height. And that value is equal to half D1, D2. Wherein you know the length of one diagonal and you'll have to find the length of the other diagonal. See here. First, find the area for rhombus. First, find the area of the rhombus. Base into height, 24 centimeters square. Now, the area of the rhombus is 24 centimeters square. The same will be the value for half D1, D2. Half D1, D2 is also a formula to find the area for rhombus. So when you find the area of this rhombus using the formula half D1, D2, you should get the same answer, 24. Area of the rhombus is 24 centimeters square. The other formula to find the area for rhombus is half D1, D2. So when you use this formula half D1, D2, the answer should be 24. The area should be 24. So half D1, D2 is equal to 24. Half into the length of one diagonal is 8 into D2 is equal to 24. So 2 ones are 2 fours are. 4 D2 is equal to 24 or D2 is equal to 6. So the length of the other diagonal is 6 centimeters. Please write down, children. Please write down. Done, children? Okay, let me know once you're finished. Let me know once you're finished. Okay. All right. Kirtana?
Oh, 1 minute, I'm doing it.
Yeah. So since we're given the base and altitude of the rhombus, we first find its area using the formula base into height. The area of the rhombus should be the same, whichever formula you use. We used base into height because we know the value of the base and height. Now, if you find the area of the same rhombus using the formula half d1 d2, the value of the area should be the same, 24 centimeters square. So which means half d1 d2 should also give you 24. With the help of this equation, we find the length of the other diagonal d2, 6 centimeters.
Finished, ma'am.
Yeah. The floor of a building consists of 3,000 tiles, which are rhombus shaped, and each of its diagonals are 45 centimeters and 30 centimeters in length. So the shape of the tiles, rhombus. Now we can find the area of the rhombus using two formulae. One is base into height, if base and height are given. The other is half d1 d2. So here we are given the length of the diagonals. So we can find the area of the you can find the area of each tile, each rhombus shaped tile using the formula half d1 d2. That's one thing. And you can find the area of one tile and multiply that by 3,000 to get the area of 3,000 tiles, which is nothing but the area of the floor. Because the floor of the building consists of 3,000 tiles. When you find the area of 3,000 tiles, you have found the floor area of the building. Area of rhombus is equal to half d1 d2. So you have the area. Multiply that is the area of one tile, one rhombus shaped tile. The area of one rhombus shaped tile is whatever, half d1 d2. Multiply that by 3,000. That will give you the area of 3,000 tiles, which is also the floor area of the building, because the floor is made up of 3,000 tiles. Okay, so now you know the floor area. Now you know the floor area because you know the area of 3,000 tiles, and the entire floor is covered with 3,000 tiles. So the area of 3,000 tiles is equal to the area of the floor. Now find the total cost of polishing the floor. If the cost per meter square is ₹4. So for 1 meter square, see the diagonals are given in centimeter. The lengths of the diagonals are given in centimeter, but the rate is given per meter square. To polish 1 meter square of the floor, you have to spend ₹4. 1 meter square, ₹4. 2 meter square, ₹8. 3 meter square, ₹12, and so on. So whatever is the floor area. So if the floor area is 100 meters square, 100 into 4, ₹400 will be the total cost of polishing the floor. We need to find the area because see the rate. See how the rate is given. 1 meter square. Square units is always a unit of area. 1 meter square. You should not find the perimeter of the rhombus here. Perimeter is just the length of the boundary. Where is the tiling work done? If this is the floor, where is the tiling work done? In the area of the floor. The tiling work is done in the area portion. Not if it's fencing, it's perimeter. If it's something about fencing. Okay, so this is the floor. Tiling is done here in this area portion. This portion. This is the area. This is the area of the room. This is the perimeter. This is the perimeter. If it's something regarding fencing or compound, that is to do with the perimeter of the building or the park or plot or whatever it is. So tiling work is undertaken in the area part of the floor, not the perimeter. So we need to find the area of one tile, multiply that by 3,000 to get the area of 3,000 tiles, which also represents the floor area, but the area will be in centimeter square. You need to convert that to meter square and then multiply by the rate to get the total cost. 1 meter square, 4 rupees. So if the floor area is 100 meters square, 100 into 4, 400 rupees will be the total cost of polishing the floor. So what you're going to learn here is how to convert centimeter square to meter square. How to convert centimeter square to meter square. Let's see the answer. See here? How do we convert centimeter to meter? Divide by 100. Centimeter square to meter square. Whatever action you perform, do it 2 times. Whatever action you do, do that 2 times. So this is the area of 3000 tiles. This is the area. This is the area of 3000 tiles or the floor area, Now this is in centimeter square. To convert it to meter square, divide to convert centimeter to meter, we need to divide by 100. To convert centimeter square to meter square, divide by 100 2 times. So it's dividing by 10,000. So see here, you can see here in the denominator, we divide by 100 2 times to convert centimeter square to meter square. You're dividing by 100, again dividing by 100. You're dividing by 100 and again dividing by 100 to convert centimeter square to meter square. So here we have the floor area in meter square. Now area into rate will be the total cost. Please write down, children. So floor area is 202.5 meters square, and then the cost of polishing, which is area of the floor into rate. Alternatively, please listen, children. Alternatively, you can convert 45 centimeter and 30 centimeter to meter. Before you find the area, what you can also do is D1 is 45 centimeter. How do you convert this to meter? 45 by 100. So you can just leave it like this, so many meters. D2 is equal to, no, I'm just telling you the alternate method. You can do it like this, or you can convert these values 45 centimeter, 30 centimeter to meters. So you'll get the area directly in meter square. If you want, you can also do this. But this will be more convenient actually. Convenient. 30 centimeter divide by 100. Centimeter to meter divide by 100. Divide by 100. So you can use these values for D1 and D2 and find the area in meter square straight away. D1 is 45 centimeters. To convert centimeter to meter, divide by 100. So 45 by 100 meters. Similarly, 30 by 100 meters. So now we have D1 and D2 in meters. So when you find the area using the formula half D1, D2, your area is already in meters square. So you don't have to convert again by dividing here like this. You don't have to, this step is not needed. You will directly get the answer as 202.5 meters square. Okay. Is it over, children? Let me not disturb you with this question. Once you're done, please acknowledge so that we can go to the next one.
Completed, ma'am.
Completed, ma'am.
All right. Tiling is done in the area portion, not the perimeter. Tiling is not done along the boundary. Tiling is done in the area portion. So we have to find the area of one tile, multiply by 3000 to get the area of 3000 tiles, which is nothing but the floor area. But that is in centimeter square, so convert it to meter square and then multiply by the rate to get the total cost. Mohan wants to buy a trapezium shaped field. Its side along the river, you can see the figure there. Its side along the river is parallel to its side. You can see the trapezium shaped field in the middle. Its side, so one side of the trapezium shaped field is along the river. Its side along the river, so that means this side along the river, this side which is along the river is which is parallel to, and sorry, its side along the river is parallel to and twice the side along the road. Okay, so these are the two sides, these are the two parallel sides of the trapezium. One side is along the road and the other side is along the river. The two parallel sides, they're talking about the two parallel sides. See here is parallel to. The side along the river is parallel to and twice the side along the road. Let's understand that. See, so they're talking about this trapezium shaped field. This is the side along the river. This side which is along the river, its side along the river is parallel to. This side is parallel to. So it should be parallel to this. That's what is mentioned here. Is parallel to and twice the side along the road. So this is the side along the road. This is the side along the road. So these two sides are parallel. The side along the river is parallel to the side along the road. That's one thing. And then this one is twice. This one, it's given. See here, along the river is twice. Along the river is twice, is parallel to and twice the side along the road. So that means this is double. This is twice. This is twice. That means if you call this x, this will be 2 times x. If the length of the side along the road is x, if the length of the side along the road is x, then the length of the side along the river is 2x. Given very clearly. See, its side along the river. Please read this. Side, this is the side along the river. This is the side along the road. The side along the river is parallel to the side along the road. That's one thing. And the side along the river is twice. It's a compound sentence, you know. It's given, two things are given in the same sentence. So you can ignore this. I'll just remove this as parallel to. I'll just remove this parallel to, and it's a compound sentence. You can see they've connected it using this word and. Okay, let's just remove this and read now. Yeah, its side along the river is twice the side along the road. You can read it one by one. So first you read like this. Its side along the river is parallel to the side along the road. This is one information. Please read only the bracket. Don't read and twice. Don't read this after and. Don't read this. What do you understand? Its side along the river is parallel to the side along the road. Is that clear, children?
Yes, ma'am. Yes, ma'am.
Now let's read the other information. Let's read the other one now, which is after and. Which is after and. So its side along the river. We'll not read this. Oh, sorry. We need yes. Its side along the river is. Now this parallel to we already read. Its side along the river is twice the side along the road. So two things are given. So river is twice along the road. The side along the river is twice the side along the road. So that means if the road is x, The side along the road is x, then the side along the river is 2x. If the area of this field is 10,500 meters squared and the perpendicular distance between the two parallel sides is 100 meters, find the length of the side along the river. So what is the formula to find the area of a trapezium? What is the formula to find the area of a trapezium?
B, breadth and height, ma'am.
Not clear? Come again?
Ma'am, 1/2 into sum of parallel sides into distance between parallel sides, ma'am.
Very good, very good. Half sum of the parallel sides into distance between them. So see here, half. What is the sum of the parallel sides? Tell me the lengths of the parallel sides. What are the lengths of the parallel sides? We have assumed, right?
X and 2x, ma'am.
Correct. So this is the sum of the parallel sides, x plus 2x. Into the distance between them. What is the distance between them?
100 meters, ma'am.
100. So this is the formula to find the area of a trapezium. Half sum of the parallel sides. We do not know the lengths of the parallel sides, so we have assumed them to be x and 2x. So half sum of the parallel sides into distance between them is equal to, what is it given? 10,500. See, we have assumed everything is in meters, children. 100 meters, x meters, 2x meters, all in meters. See, when you construct an equation, and if the numerical values involved, the numerical values and as well as the variables you assume, all of them except the constants. So now half is a constant, half. The other values must be in the same unit. You cannot have some in centimeter, some in meter. No. X meters, 2x meters, 100 meters, 10,500 meters square. See, meter is important. Area, so meter square it is. That's very important. In an equation, both the sides must have the values in the same unit. Meter, centimeter, kilometer should be the same throughout. All right, so we have substituted. And why did we use the area formula? Because we are given the value of the area, 10,500 meters squared. We are given the value of the area. All right, so how do we simplify this? Yeah, how do we simplify this?
1/2 into 3x
Very good.
into 100 is equal to 10,500, ma'am.
All right, next.
3x into 50.
Yeah, good.
It is equal to 10,500, ma'am.
Okay,
And
next.
3x is equal to 10,500 by 50, ma'am.
10,500 by 50. Very good. So 0 gets cancelled and it will be 5 2s are 1 0. Correct? 210.
Yes, ma'am.
Yeah.
X is equal to 210 by 3, ma'am.
Very good. So x is equal to 70. 70 what? What's the unit? 70 meters.
Meters, ma'am.
70 meters. Now what are we asked to find? Find the length of the side along the river. Along the river is 2x. Therefore, the length of the side along the river is equal to 2 into 70, 140 meters. Correct?
140 meters, ma'am. Yes, ma'am.
Correct. Yes, children, please write down. You don't have to mention the length of the side along the road because that's not asked. They only want you to write the length of the side along the river. So just mention that. Done, children?
Yes, ma'am.
Completed, ma'am.
All right. All right, children. Next one. Top surface of a raised platform. The top surface of a raised platform. So maybe the it could be the top, a tabletop. It could be a tabletop. So the top surface of a raised platform is in the shape of a regular octagon. Regular octagon. An octagon is an eight-sided polygon. A regular octagon is one in which all the sides, all the eight sides, and the eight interior angles are equal. An octagon, yeah, an octagon is an eight-sided polygon. A polygon with eight sides is an octagon. And if all the eight sides are equal and the interior angles are also equal, then it's a regular octagon. So which means each side is equal to 5 meters, because one of its sides is given here. You can see here. One of the sides is marked 5 meters. So everywhere it is 5 meters, 5 meters, 5 meters, 5 meters, everywhere, everywhere. Each of the 8 sides is equal to 5 meters. Because it's a regular octagon, all the sides are equal. So the top surface of a raised platform is in the shape of a regular octagon as shown in the figure. Find the area of the octagonal surface. Find the area of the octagonal surface. Tell me, how would you divide? You'll have to divide this, octagon into some number of plane figures, some plane figures. How will you divide this octagon? See, you cannot connect anything to anything. You should be able to find. So when you make plane figures, when you connect and make, you know, 2 or more plane figures from this octagon, you should be able to find their area.
Ma'am?
Yeah.
Ma'am, we can make 2 trapeziums and 1 rectangle, ma'am.
Yeah, this is the answer I wanted. Very good. You can divide the octagon, you can divide the regular octagon into 2 trapeziums and 1 rectangle by joining these 2 vertices. By joining these 2 vertices. Correct. So we could join these 2 vertices and divide the trapezium, and divide the octagon into 1 trapezium here, and a rectangle here. So these are the parallel sides of the trapezium. For this trapezium, these are the parallel sides. These are the parallel sides. What's the length of this side? What's the length of this side?
5 meter, ma'am.
5 meters. What is the length of this side?
11 meter, ma'am.
7 meters. What is the distance between the parallel sides?
4 meter.
4 meters.
4 meters. So half sum of the parallel sides into distance between them. So we have all the information we need to substitute in the formula. So just, you know, fix the values in the formula and compute its area. So the same will be the area of the other trapezium. The same will be the area of the other trapezium. And what were the length and the breadth of the rectangle?
Ma'am, 11 meters the length and 5 meters the breadth, ma'am.
Perfect.
11 into 5, we can get the area.
Correct. So just find the areas of the 3 plane figures, add to find the area of the octagonal surface. Please complete the answer, children. Let me know once you're done.
Completed, ma'am.
All right.
Completed, ma'am.
All right.
Ma'am, 1 minute. Can you show the last slide, ma'am? I was writing.
Yeah, sure.
Finished, ma'am.
Okay. Next one. There is a pentagonal shaped park as shown in the figure. Okay, there's a pentagonal shaped park as shown in the figure. For finding its area, Jyoti and Kavita divided it in two different ways. So you can see Jyoti's diagram and Kavita's diagram there. Find the area of this park using both the ways. Can you suggest another way? Can you suggest some other way of finding its area? So that question is for you. Can you suggest some other way of finding its area? That question is for you. We'll find the area using Jyoti's way and Kavita's way. Let me see. Take this as a test, children. Take this one as a test. Try this by yourself. Find the area using Jyoti's method and let me know once you're done with that. So what's the area of the pentagon according to Jyoti? What's up, children?
Yes, ma'am.
Yeah, so how has Jyoti divided the pentagonal shaped park? What are the two plane figures there?
They are two trapeziums, ma'am.
Very good. What are the lengths of the parallel sides?
30 and 15, ma'am.
Very good. And the distance between them?
15 by 2. Height, ma'am.
15 by 2 or 7.5 or simply 15 by 2. Very good. What's the answer?
337.5 meters square, ma'am.
337. No, oh, you okay. Oh, yeah, that will be the area of one trapezium. So both will be 337. Correct. You're right, Danya. What about Kavita's approach? Please do that. Done, children? Kavita's method? What are the two plane figures we see in Kavita's method?
One triangle and one square, ma'am.
Okay,
Triangle and one square, ma'am.
correct. So what's the side of the square?
Ma'am, 15 meter each, ma'am.
Side of the square is 15 meters. And how do we find
Area
the triangle? How do we
ma'am.
find the triangle?
Ma'am, 15
Side square, ma'am.
A square, ma'am. 15 into 15, ma'am.
Okay, area of the square. Area of the square is side square 15 into 15 to 25 meters square. Fine. How did we find the area of the triangle?
1/2 into base into height, ma'am.
Half base into height. What's the length of the base?
15 meter, ma'am.
15. Yeah, it's 15 because this is 15. This one is 15. So opposite sides are equal. This is 15. This is 15 given. This is 15. Opposite sides are equal. So this will be 15. Now you see that all the sides are 15. So these three 15s are already given in the question. When you join this, this also is 15. So since all the sides are equal, it's a square. Area of the square, a square square units. Then for the triangle, half base into height. What's the base? How much is the? What about the height?
15 meter, ma'am, because total height is 30 centimeter. Minus 15 meter is 15, ma'am.
Correct. Correct. So from here to here. See this one. From this point to this point, the length is 30. It's given here. You can see it here. This complete height of the figure, this full height from here to here is 30, is given here. You can see it here, it's given 30. So from here to here is 30, from here to here is 30. And this alone is 15, this alone is 15. So the remaining part will be 30 minus 15, which is 15. Let's see that again. This full thing, the length of this line segment is 30 meters, is given here. And this one is 15, which means from here to here is 15. From here to here is 15. So the length of this portion will be the whole thing 30 minus 15. This will be 15. So half base into height, half 15 into 15. Base is 15, height is also 15. So either way, the area of the pentagon. Either way, the area of the pentagon is 337.5 meters square. First, read the contents of the slide, children. I'll give you some time for this. Please read the contents of the slide and then write down. If you've already tried it correctly, fine. If you were not able to, please write down. Done, children?
Yes, ma'am.
Yes, ma'am.
All right. No, nobody told me. You just finished or you've been waiting for me? Because I've been waiting for you, all of you. Just finished, right?
Yes, ma'am.
Yeah, and any questions, children? See, this full thing is 15. So CD will be 15 by 2. DE will be 15 by 2. Half of it, half of 15. The parallel sides of the trapezium. See here, these are the parallel sides of the trapezium. 15 and 30. And this is the distance here. These are the parallel sides of the trapezium. These two are the parallel sides of the trapezium. This is the distance between them. This is the trapezium. On one side, parallel sides. 15 and 30. Distance between them is this one, which is 15 by 2. The same thing we have on the other side also. Parallel sides 15 and 30, distance between them 15 by 2. So you find the area of one trapezium and double it to get the area of the pentagon. So here this is 15, so this is also 15. It's a square. Find the area of the square. And then the triangle. See, this is 15, so we got this one is also 15. This is 15. Base into height 15. Base into height 15. How is this 15? Because the full thing is 30 and from here to here is 15. So this remaining part will be 15. All right, the next one. The picture frame has outer dimensions 24 centimeters by 28 centimeters and inner dimensions 16 centimeters by 20 centimeters. You can see that you can see those dimensions represented in the figure. Find the area of each section of the frame if the width of each section is the same. Okay, so this is a picture frame. So here is the picture. Here is the picture. Here's a picture. This is the frame. This is the frame. So this portion here, this rectangular portion, is where you will place the photograph or whatever picture it is. This portion, this rectangle is where you will place the photograph or the picture. This one is the frame. These portions are the frame. There's only one frame. These are the different parts of the frame. So this one, these are the parts of the frame. Now what is given? The dimensions are given. The outer and inner dimensions are given. Find the area of each section of the frame, children, not this one. Okay, so here is where we have the picture. Here is where we have the picture. All right.
Yes, ma'am. Yes, ma'am.
Yeah. And these are the parts of the frame. So you need to find the area of each section of the frame. So section 1, section 2, section 3, section 4. These two sections will have the same area. Sections 1 and 2 will have the same area. Sections 3 and 4 will have the same area. So you find the area of section 1, the same will be the area of section 2. Find the area of section 3, the same will be the area of section 4. The width of each section is the same. The width of each section is the same. This width, this is the width of the section, this one. This is the width of the section. This is the width of the section. This is the width. This is the width of the section. So from here to here, what is it from here to here, children? How much is it from here to here?
20 centimeter, ma'am.
28. How much is it from here to here?
20 centimeter, ma'am.
20 centimeter, ma'am.
20. So this full thing is 28. From here to here is 28. But from here to here is 20. What's the difference? 28 minus 20?
8, ma'am.
8. So 8 by 2. So this width is 4. The uniform width of the frame is 4 centimeters. The uniform width of the frame is 4 centimeters. Let's see that again. So this one, the length of this line segment is 28 centimeters. The length of this line segment is 20 centimeters. This is 20. So 28 minus 20, 8 divided by 2, 4. So the width of the frame is 4 centimeters. Now let's find the area of each section of the frame. Each one is a trapezium. Each one is a trapezium. These are the parallel sides. And there's the distance between them, which is 4 centimeters, which we just found. So how much is this one? What's the length of this parallel side?
16 centimeter, ma'am.
16. How much is this? How much is this one?
24 centimeter, ma'am.
24. What's the distance between them?
4 centimeter, ma'am.
What's the formula to find the area for trapezium?
1 by 2 into 1 by 2 into sum of parallel sides into this and into distance between parallel sides, ma'am.
Half sum of the parallel sides. The parallel sides are 16 and 24. 16 and 24, and the distance between them is 4. So that is about the area of this frame and this frame, 1 and 2. Now let's talk about the dimensions of the frames 3 and 4. These are the parallel sides. What's the length of this side? How much is this?
20 centimeter, ma'am.
20. How much is this one?
28, ma'am. 28, ma'am.
So the parallel sides. See, this is the trapezium. This is the trapezium. This is the trapezium. Parallel sides. This is 28 because the opposite side is 28. And this is 20. What's the distance between them?
8 centimeter. 8 centimeter, ma'am. 4, ma'am. 4 centimeter, ma'am.
Yeah, because the same thing. It's given that the width is uniform, but you can even work it now. This whole thing is 24. From here to here, see, from here to here is 24 because you can see it here. This one is 24. So from here to here, this one is 24. But from here to here, it is how much?
16, ma'am.
16. This the length of this line segment is 24, but this portion is 16. So 24 minus 16 is 8. 8 divided by 2, 4. 4. See, 4 in this 16. Correct, children?
Yes, ma'am. Yes, ma'am.
All right. So the width is 4 and the parallel sides, this one is 20 and this one is 28. 20 and 28. 20, 28 are the parallel sides, distance between them 4. So like this, find the area of section 3 and 4. You don't have to add everything because you just have to find the area of each section separately. The total area of the frame you should add. If you're asked to find the total area of the frame is different. The picture frame alone. So here it is, find the area of each section of the frame. So just leave the answer like this.
Completed, ma'am. Completed, ma'am.
Very good.
Completed, ma'am.
All right.
Completed, ma'am.
Good. As we come to the end of this exercise. All right. All right, children. Now, consider a cuboid. Okay. Now, this is the length, right? This is the length, right?
Yes.
Now, what you should understand is, what you all know is that a cuboid has 6 rectangular faces. The front face and the back face have the same dimensions. The 2 side faces will have the same dimensions. The top and the bottom face will have the same dimensions. That is, the front and back are congruent. They look alike. The front face and the back face. The front face, see, this is the front face. This is the front face. This one is the, see, this one is the front face. This front face and the back face. This is the back face. This is the back face. These 2 faces will look alike. Okay, so we know that this is the length of the cuboid. This is the breadth of the cuboid. And this one is the height of the cuboid. Am I right, children?
Yes, ma'am.
This is the length of the cuboid. This one is the breadth of the cuboid. And this is the height of the cuboid. Now, the front face is a rectangle, correct?
Yes, ma'am.
And area of the rectangle will be L into H. Because this is L and this is H. L into H will be the area of the front face. Am I right?
Yes, ma'am. Yes, ma'am.
Children, we are not finding anything of the cuboid. The cuboid is made up of 6 rectangular faces. We are trying to understand the area of each of the rectangular faces. The front and back face will have the same area. The 2 side faces will have the same area. The top and the bottom face will have the same area. So the opposite sides are congruent. They are equal. The opposite sides, the opposite faces. The opposite faces are congruent. Okay. So this is for the front and the back. This is the back face. This one is the back face. This one is the back face. This is the front face. The areas of these 2 faces. Okay, the area of the front face is L into H, correct?
Yes, ma'am.
What's the area of the back face? What's the area of the back face?
L into H, ma'am.
L into H. L into H. Now coming to the 2 side faces. That side faces. This is one of the side faces. This one. See here. This one. I hope you can see me annotating. This is one side face, right? This is one side face. How much is this? How much is this? Meaning, what is this called? B, right?
Yes, ma'am.
And this one?
Height, ma'am. Height, ma'am.
Height. So what will be the area of the side face? Breadth into height.
Yes, ma'am.
Breadth into height. Keetna and Danya?
Ma'am?
Yes, ma'am.
Correct?
Yes, ma'am.
What will be the area of the other side face? This one? This side face?
B into H, ma'am. B into H, ma'am.
B into H, because this one is B, this one is B, and this one is H. Now, when you look at the top and bottom faces, the top face, what is this in the top? Length. This is the length. And this is the breadth. The top and bottom faces. See the bottom face? See the bottom face? This is the bottom face. This one is the length, L. And this is the breadth. So the area of the top face and the bottom face each will be L into B. L into B. Let me ask you again. I'm not a good artist. Okay. Yes, children. Now tell me, this is the length, this is the breadth, and this is the height. The regular way, nothing different. Now, what is the area of the back face? Back face.
L into H, ma'am. L into
H.
H, ma'am.
Front face.
L into H, ma'am.
L into H, ma'am.
Square units. Side face.
B into H, ma'am.
B into H. The side faces B into H. Top face.
L into B, ma'am.
L into B. L into B. This is L. This is L. This is B. L into B. Bottom face.
L into
L into B. All right, children. So I think this answer you can understand. Just take its time. Please take a screenshot and complete this one.
Taken, ma'am.
All right. Yeah, I did not read the question for you. Please help yourself. We'll see it in the next class in case you have any doubts. All right, children. So that's it for today's session. Thank you so much. Good night.
Thank you, ma'am.
Thank you, children. Good night.
Thank you, ma'am.
Thank you. Good night.
Thank you, ma'am. Good night,
Thank
ma'am.
you. Thank you. Good night.